Batter up. It is Wise Guy Wednesday, and today we're going to look at the science behind baseball bats.
We've been talking a lot about Sammy Sosa and the whole corked bat issue, and you've got some physics explanations for us about why that he may, well, we don't know if he actually did that or not, but obviously it was an issue, so why people may consider doing it.
People are interested in baseball right now for this and sort of the science behind hitting balls and so on, and so that's what we're going to talk about today. And so I have a corked bat, kind of, that I'll show in the next segment, and we'll discuss why that may or may not help anybody hit. But I thought we would review what it takes to hit a baseball far. Okay. And there's so many things in addition to physics going on here, and there's a lot of physics too, right? You know that it helps to be a big beefy guy, like some of these long ball hitters are have muscle. But that's not all, because Sammy Sosa is not the biggest guy ever played baseball, but he hits it. So you have to have that finesse, that touch, and that's why baseball is so interesting to people. And so one of the important things is to find the sweet spot on your bat. And if you can find that place, and if you've ever played baseball, you know that there's a certain place along the bat where you hit it, it just sounds right. It feels good, it sounds good. It's a sweet spot. Okay, and now we talked about this a few weeks ago, actually, and I didn't give you the whole story, and now that we've talked about vibrations, I can give you the rest of the story, as it turns out. So, very interesting fact. If you find where the middle of the baseball bat is, that is not where you want to hit it if you want the ball to go far. Because if you hit the bat, oops, I'm going to put it this way so you can see the other end of it. If you hit the bat there, the handle moves as well as the front of the bat, so that means that your hand would hurt because the end of the bat hurt. If you hit it a little farther out, then what happens is the bat rotates and the handle stays fixed. And so what you find is that if you hit the ball at the sweet spot or a little farther out, you don't feel vibrations or pressure on your hand. But there's more reason for that. The other reason that it sounds kind of crappy if you hit it there and it sounds really good when you hit it on the sweet spot, is that the baseball bat actually vibrates. And we've talked about resonance and vibrations already, and baseball bats, like anything else, is like the wine glass, has a natural vibration frequency and mode. Okay, and so if let's pretend this ruler, which is very flimsy, is a baseball bat. If I vibrate it, you'll see that there's a spot at the top here where it's not moving. So this is a vibrational mode of this particular stick, and it has a node up here where nothing is moving.
And that node is the sweet spot?
And that node is, in fact, very, very closely related to the sweet spot. So when you hit a bat, that sound you hear has to do with the bat vibrating, and you want to hit it so that the ball hits this node where nothing vibrates, because if you hit it away from that spot, that means that you can get those vibrations started, and that wastes energy and it hurts your hand.
And we don't want to waste energy when we're hitting a baseball or softball.
That's right. And so it just so happens that in baseball bats, this node of vibration is in almost the same spot exactly as this center of percussion, the place that you want to hit it so that the handle doesn't move. Okay, and so even though people who maybe designed baseball bats didn't really realize that this is what they were doing when they first built these bats, they just knew how to make them so they felt right. The reason they feel right is because of this nice coincidence, and so you can hit the ball very far. And so one of the tricks for hitting a baseball really far is to get it exactly on the sweet spot, of course, and you have to aim it just right, and you have to swing it very, very hard, and we'll get to that in the second segment with the cork bat.
So there would be a reason why someone might change that, because it can change how the bat would hit?
That's right. So you'd want to be careful that you didn't, in fact, if you want to drill a hole in it and put cork in your bat, you probably don't want to change that, because you don't want to mess up your sweet spot. And as it turns out, putting cork in the bat really doesn't change very much, so it doesn't change the sweet spot significantly at all. What it does do is it makes the bat a little bit lighter so you can swing it faster, and so that's the reason that people think it actually makes you hit farther. But having talked to some scientists and some experts about this in the last few days,
we'll have some answers coming up.
We'll have some answers about that. It's not clear that's how it really works.
Okay, well, stay tuned for that later on the morning show. Also today, we're going home on the range in today's Wish You Were Here postcard.
And a rocky